All right, guys, I'm going to go through a couple of Delta Math examples. You are going to want to write this down because these are the exact questions that you're going to see on your 2 of your 4 Delta Math problems. So here we go. First thing you're going to want to do is try to draw a picture of what's happening in your problem. So this first example, we are drawing cross sections that are perpendicular to the x-axis, and those cross sections are isosceles right triangles. So we are going to go to our shape. Our shaded space is kind of like the base of that. So this is the base of where I'm going to build my triangle, and I'm going to try to make it look three-dimensional, But basically what I'm doing is here's the base, and it's supposed to be isosceles right triangle, which means that this side is equal to this side. Okay, so let's start with how do you find the area of an isosceles right triangle? To find area, you need to compute 1/2 the base times the height. And like I said, in this case, the base and the height are the same measurement, so we could simplify that and call it 1/2 the base squared. All right, that's step 1. Step 2 is you're going to go to your graph and you're going to say, all right, I know I need an antiderivative. The concept is I want, an infinite number of these right triangles, and I want to add them all up to find the volume. So I kind of need to see the space where all the triangles are going to be. So they're going to start when x is 0, and they're going to stop when x is whatever that value is. So you run over to Desmos, you graph each of your functions, and you want to see where they cross. And that x value is going to be the x value in your interval. So it is 1.619. If we round it a little bit, that works. And then in here, we're going to put our our area of one triangle. We're going to put that equation. And then we drew our triangles with respect to x. So we would want perpendicular, I guess, to the x-axis. So we'd want dx. Okay, here's where the hard part comes in. So the hard part comes in where you have to make a few changes because this is a letter b and this is x, and those have to be the same in order to be able to actually do the antiderivative. So how can I compare the base of this triangle to something with x's? Okay, so this is where you're going to look back at the problem and you're going to say, okay, the equations of these lines have something to do with it. So this straight line was 5x plus 2. This curved function was 2e to the x. The distance between those two lines is the same as the distance or the length of the base of our triangles. So to write down the base measurement of each triangle, we would want to write it in respect to the distance from the straight line to the curved line. Okay, so the distance from the straight line to the curved line just comes from subtracting whatever is on top, which is the straight line, minus the curved line, which is on the bottom. So I'm going to replace the base b with 5x plus 2, because that's the straight line which is on the top of that shaded region, minus the curved line equation, and that's going in place of b. So we do still have the 1/2, and we do still have squared, and we have dx. So this is what your setup is going to look like, and truly you're going to basically from here go straight back to Desmos and let Desmos do the work for you. So let me show you how that's done. In Desmos, you're going to need, you don't need the volume part, but you are going to need 1/2. You go to your little calculator down here. Get to my little calculator. Hold on. Okay, I can't get to my calculator button. But You go to your little calculator button, there's an antiderivative symbol that you can drop in, and you can type all this stuff in there exactly as it's shown. You can also do this on your graphing calculator, but basically you're not anti-driving any of this by hand if you don't want to, because I am more concerned with you being able to set the problem up than I am with you being able to solve on your own. So anyway, answer for this one would be 1.069. Let's do one more. Okay, in this example, we have f of x equals x to the 1/3 power, g of x equals 1/4 x, and we are drawing cross sections perpendicular to the x-axis that are rectangles. Okay, so these are rectangles, so I'm just going to draw one for a visual. So that's the base of the rectangle, kind of like this, and I like to go over here and redraw what I was trying to do there. Now, it says in the problem that these rectangles you're going to draw, the height is twice the length of the base. So if the base is b, the height is 2b. Okay, next step would be write down how you find area of a rectangle. For this particular rectangle, it would be length times width, or 2b times b, which simplifies to 2b squared. Okay, now what you would want to do next is you would want to go to your Desmos, go to Desmos again, and you want to see what are my x values where this region starts and stops. So I can tell it starts at 0. Where does it stop? It stops right here where they intersect. You could verify this value on Desmos, but I believe it is just 8. And this is where you put in your area of one rectangle. And remember, the antiderivative kind of like finds the area of each rectangle and adds them all up for you. So that's why you just put the area of one here, and then the antiderivative will do the adding part. And then we drew the rectangles perpendicular to the x-axis, so dx. And again, this is the hard part here, is we have to make these variables match. So I need this to be an x in order to be able to continue. I'm going to go ahead and move the 2 out of the integral as well. Again, that's not something that's necessary. I just prefer that. Okay, so how do I change this to an x? Well, I'm going to look at the rectangle I drew, and I'm going to think about how the distance, the length of the base, how that relates to these equations that are given here on this graph. So this curved equation that is on the top, that is the graph of x to the 1/3. This straight line is the graph of 1/4 x. Again, you can confirm that using Desmos. So basically, if I want to find this distance, I would need to do x to the 1/3 minus 1/4 x. So back to your equation, you are going to replace the b value with x to the 1/3 minus 1/4 x. You would still have the squared, and you would still have dx. And now that everything is written in terms of x, you can type all this into Desmos just the way you see it right here, and you would get an answer of 4.876.